beneath America's biggest cities, mountains, and deserts lies a hidden world. A world of underground factories, nuclear bunkers, secret military complexes, and engineering projects so vast they rival entire cities. And then there are the places we weren't supposed to know about at all.
We have built an extraordinary number of underground bases and supposedly transportation systems. Some of these are documented as part of the national security infrastructure. I think there are many more. So,
in the United States?
In the United States, and all over the world.
One secret government facility remained hidden for years and was only publicly exposed after a plane crashed into the mountain above it. That raises an uncomfortable question: how many others remain hidden? It's a question that has fueled decades of speculation. Are the known bunkers and tunnel networks simply practical infrastructure? Or are they clues to something larger, a vast underground America stretching far beyond what the public can see? From documented megaprojects carved into mountains to the conspiracy theories they inspired, this is the story of America's underground cities. 150 feet beneath Kansas City, there is a road system with street signs, traffic rules, and a 15-mile-an-hour speed limit. Semi-trucks drive down it. The streets have names, and the addresses are marked by numbered stone pillars, each one 25 feet square, holding up the ceiling. There are more than 10 miles of paved, lit road down there, and 2 miles of railroad track running directly into the BNSF main line. It is always 68 degrees down there. It never rains, and no signal reaches that deep into solid limestone. This is Subtropolis, the largest underground business complex in the world, and it exists because of how the rock was taken out. Kansas City sits on top of one of the richest limestone deposits in the country, and for decades that rock was mined out of the bluffs along the Missouri River and built into the city above. Starting in 1945, an asphalt company called Midwest Precoat began mining that limestone out of the bluffs, hauling the rock away and selling it. By the 1960s, the easy rock was running out, the mining was slowing down, and what the company had to show for 2 decades of work was an empty hole in the side of a hill, going back hundreds of feet into the dark. It was held up by more than 10,000 stone pillars, with truck-sized openings at the base of the bluff because the digging had gone sideways into the hill rather than straight down. A developer leased the first space here in 1964. The first tenant was a local construction company that needed somewhere to store heavy machinery. That was the whole business at the start: cheap, stable storage in a hole in the ground. 6 decades later, it could have easily become an abandoned construction site deep underground. The qualities that made it good for storing a bulldozer turned out to make it good for storing far stranger things. The limestone holds a steady temperature between 65 and 70 degrees year-round, no matter the season on the surface. It sits above the water table, so it never floods. The humidity stays constant, which means no condensation, nothing to rust or rot, and the pillars are about 6 times stronger than concrete, with so much margin to spare that the complex is one of the safest places to be in a tornado. In theory, a company operating down there cuts its heating and cooling costs by roughly 70%. It is something the Earth does for free, which is why the tenant list grew in all directions. From food distributors to government agencies, Subtropolis houses everyone. Ford has stored cars in it. Food companies use it for cold storage. The temperature and the security also make it the kind of place you send things that can't be replaced. The original film reels of Gone with the Wind and The Wizard of Oz are kept underground, preserved in the constant cool. The U.S. Postal Service stores a copy of every postage stamp it has ever printed. The National Archives keeps federal court records and tax documents in it. Government agencies like the EPA and the federal government's General Services Administration lease spaces here. Though, by design, this has fed years of rumors about what exactly is being kept in a secure cavern under Kansas City. An interesting part of this underground city is getting in and out of it. There are no elevators and no shafts in Subtropolis. Trucks drive in at ground level through openings in the base of the bluff and navigate the grid of corridors, 40 feet wide and 16 feet high, big enough for a 53-foot semi to move through without trouble. Freight comes in by rail on tracks that run straight off the main line into the rock. More than 50 companies operate down there now, and over 2,000 people drive into the side of a hill every morning and spend the day beneath solid stone. The place has folded into Kansas City life in odd ways. Once a year since 1982, thousands of runners race a charity 10K through the tunnels, making it the only fully underground race of its kind. There's an orchid greenhouse open to the public on Tuesdays and a paintball arena in the dark side corridors. In Subtropolis, you'll find long-lit roads branching into unlit tunnels blocked with rubble, disappearing into black. Patrick Mahomes, after seeing it, compared it to a villain's lair. And it's still being dug. Only a fraction of the 55 million square feet of mined-out space has been developed, and the mining never fully stopped. On the far edges of the property, crews are still pulling limestone out of the ground, selling the rock and extending the cavern at the same time. A distribution center opening in 2026 is expected to be the largest underground distribution facility in the world. Every blast on the working edge of the mine sells a load of limestone and carves out the next block of the underground city in the same motion. In 1957, the Soviet Union launched Sputnik. The Cold War was approaching its peak, which meant the same rockets that put a satellite in orbit could put a warhead on an American city. The military wanted a command center that could keep running after a nuclear strike landed on top of it, and 2,000 feet of solid rock was the plan for how it would survive. Cheyenne Mountain was a triple-peaked mass of Precambrian granite on the edge of the Rockies, just southwest of Colorado Springs, and in the spring of 1961, the U.S. Army Corps of Engineers began drilling into it with the intention of hollowing it out. Crews used more than 500 tons of dynamite, set off in carefully timed sequences to avoid shattering the surrounding rock, and over 3 years they removed nearly 700,000 tons of granite from inside the mountain. The work was dangerous and contentious. Worker protests threatened to derail the project, and the engineers hit a geological fault running through the ceiling of one of the main intersections, a crack in the rock that threatened to bring the chamber down. They had to reinforce it with a massive concrete dome that cost $2.7 million on its own. What they eventually built inside the hollowed-out mountain was a work of art. 60-feet-high chambers were carved into the granite. Rather than building directly on the rock floor, the engineers constructed 15 freestanding steel buildings, some of them 3 stories tall, and set them on top of more than 1,300 enormous steel springs, each one weighing about 1,000 pounds. The buildings don't touch the mountain. They sit on the springs, so that if a nuclear blast slammed into Cheyenne Mountain, the whole complex could rock and sway with the shock instead of shattering against the rock. It's an entire installation built to ride out the end of the world, like a ship on water. The way in runs through a tunnel bored almost a mile through the granite. It is a curved tunnel so that the force of a nuclear blast at one end would blow straight through and out the other rather than into the complex. Set into the side of that tunnel are 2 blast doors, each one 3 feet thick and weighing 25 tons, rated to withstand a 30 megaton detonation less than 2 miles away. When they swing shut, they seal the complex off completely. Behind them, the place is built to survive on its own for as long as the people inside can hold out. It has its own power plant running on diesel generators, its own air supply filtered against chemical, biological, and radioactive contamination, and underground reservoirs holding millions of gallons of water. During construction, the reservoirs were so large that workers crossed them in rowboats. They still hold so much water that the staff sometimes use small boats to get across. The complex went fully operational in February 1967, and from that point on, it watched the skies every hour of every day. NORAD, the joint U.S. and Canadian command responsible for spotting an attack on North America, ran its operations from inside the mountain, taking in data from early warning radar and satellites around the world and processing it for the one thing everyone was afraid of: missiles inbound over the pole. Twice, the system said they were. On November 9, 1979, the screens inside Cheyenne Mountain lit up with a full-scale Soviet missile attack. Crews scrambled, fighter jets were launched, and the airborne command post the president would use to direct a nuclear war took off. For 6 minutes, the American military believed the country was under attack until it was traced to a training tape that simulated an attack and had somehow been loaded into the live system. The following year, on June 3, 1980, it happened again. President Carter's national security advisor was woken at 3 in the morning and told that 200 Soviet missiles were inbound, then called back and told the number was 1,200. He was preparing to wake the president and tell him the United States had minutes to respond when the alert fell apart. The cause turned out to be a single faulty computer chip that was randomly inserting false numbers into the warning system. The Cold War ended, but the mountain still runs. In 2006, the main operations moved to a nearby Air Force base, and Cheyenne Mountain shifted to a backup role, though it remained fully staffed around the clock, ready to take over control of North American airspace within minutes if ever needed. And for a place built for the apocalypse, it has its lighter side. There's a small bar inside called the Granite Inn, where personnel drink under 2,000 feet of rock. The science fiction series Stargate SG-1 set its fictional secret base inside Cheyenne Mountain for 10 seasons, and in response, the real facility hung a sign reading Stargate Command on a door inside the mountain. Behind the door is a broom closet. There's also a Subway sandwich shop down there that, according to the people who work in the most heavily fortified installation in the country, greets its customers as the most secure subway in the world. Cheyenne Mountain was built to watch for the attack, but watching for it raised a harder question. If the warning ever came true, if the missiles actually landed and Washington was gone, who would be left to run the country, and from where? About 1,500 miles to the east, blasted into a different mountain, was the answer. On the border between Pennsylvania and Maryland, a few miles north of Camp David, there is a mountain called Raven Rock with a small, fenced complex of antennas and buildings at its base. The buildings at the surface are almost nothing. There's a guard post and some support structures. The actual facility is inside the mountain. The military started blasting into Raven Rock in 1951, at the very start of the Cold War. For the same reason they would later dig into Cheyenne Mountain, the fear that a single Soviet attack could decapitate the entire chain of command in one stroke. The Pentagon sits across the river from the capital, concentrated and exposed, and an enemy who destroyed it would wipe out the people who command the armed forces along with it. Raven Rock was the backup. The plan was to hollow out the mountain and build inside it a duplicate Pentagon, a place senior military leaders could be moved to where they could keep directing American forces no matter what happened to the city. A small hidden government campus was carved out of the greenstone. Inside the mountain are multiple freestanding buildings, 3 stories tall, sitting in caverns blasted out of the rock. The facility has its own power plants, its own water from underground reservoirs, and its own medical facilities. It was designed so the people inside could survive while sealed off from the outside world. People who work there have described it as a self-contained town inside a mountain, down to having its own internal roads and a chapel. For decades, it sat in the background, a Cold War relic that most of the public had never heard of. Then, on the morning of September 11th, 2001, it was used for real for the first time. As the attacks unfolded and it became clear that the people in charge of the country could be targets, Raven Rock's blast doors were sealed shut for the first time in the facility's history. Senior defense officials were evacuated into the mountain to keep the military's command structure intact. But inside, the people running the response ran into a problem. The computers inside Raven Rock were so old that they couldn't connect to the modern internet. A complex built to command a nuclear war in the 1960s couldn't get its systems online in 2001. The mountain that was supposed to keep the government running through the apocalypse couldn't reliably hold a connection to the world above it. That failure changed how the government treated the place. After 9/11, the focus on continuity came roaring back, and so did the money. The Pentagon now spends well over $100 million a year on Raven Rock, upgrading and expanding a facility that had spent the previous decades as an afterthought. The mountain that was nearly forgotten is busier now than it has been in years, kept ready for the same scenario it was blasted out of the rock to handle 70 years ago. Raven Rock was only the centerpiece. It anchored a sprawling, secret program the government has spent more than 60 years and many billions of dollars building, known as continuity of government. The scope of it is staggering. A bunker under a luxury resort in West Virginia, built to hold the entire United States Congress, disguised for decades as an expansion of the hotel. A plan to launch nuclear missiles from a Boeing 747 flying over Nebraska, plans to evacuate the Liberty Bell from Philadelphia, and the most valuable paintings in the National Gallery to safety. The government built all of this to save itself, while the rest of the population was left to fend for itself. Raven Rock was the military's mountain, 55 miles from Washington in the Virginia Blue Ridge. The civilian government had its own, and the country only found out it existed because a passenger jet flew into it. On the morning of December 1st, 1974, TWA Flight 514 was approaching Washington Dulles in bad weather when the crew, confused by the air traffic instructions, descended too early into the fog. The Boeing 727 hit the ridge of Mount Weather in Virginia at around 230 miles an hour. All 92 people aboard were killed instantly. The wreckage scattered across the mountaintop. When reporters and investigators reached the crash site, they found something on the ridge that nobody was supposed to know about. The plane had come down barely a mile from a secret government facility built into the mountain, and the press, noticing that a crash in the woods was being handled like a national security breach, started asking why. Mount Weather had started life in the late 1800s as a weather station, a place for launching balloons and kites. In the 1930s, the Bureau of Mines bored a short experimental tunnel into the crest to test mining techniques, and the rock turned out to be hard and stable. That assessment is what doomed it to its second life. In 1954, under the code name Operation High Point, the Army Corps of Engineers began turning the mountain into a bunker, and by 1959, the underground facility was complete. What's inside is a buried town built for the civilian side of the government, the place the president, the cabinet, and the Supreme Court would be taken if Washington became unlivable. The underground portion runs to 600,000 square feet. A series of side tunnels holds around 20 separate office buildings, some of them 3 stories tall, along with sleeping quarters and an emergency power plant. There's a hospital and a crematorium. There's a television and radio studio, built so that the government could broadcast whatever remained of the country from inside the mountain. The full reach of the place only came out in pieces, and it embarrassed the people who learned about it. Members of Congress discovered they had been kept in the dark about a facility their tax money had paid for, and that they were not on the list to enter. When pressed, the government admitted the site existed, but refused to say how many people it could hold or who exactly qualified to get in. The public, who had spent the Cold War being told to hide under school desks, learned that the leadership had built itself a fully provisioned underground refuge in the mountains. The strangest detail of the program shows what kind of place Mount Weather is meant to preserve. Between 1979 and 1981, the National Gallery of Art set up a plan to fly its most valuable paintings to Mount Weather by helicopter in an emergency. In the version of the apocalypse the facility was built for, the masterpieces get a seat in the mountain. It has been activated for real at least once. During the Northeast blackout of 1965, when power failed across the region, Mount Weather went to full operation for the first time. After the September 11th attacks, much of the congressional leadership was flown there by helicopter, and like the rest of the Doomsday Network, it never wound down after the Cold War. The surface grew into a 400-acre FEMA complex, and the mountain took on the newer fears of the century, coordinating disaster response and serving as a command node against attacks on the power grid and the country's computer systems. The crash that exposed it left almost no trace on the surface. For 50 years, there was no memorial at the site where the 92 people died, a mile and a half from the bunker their deaths revealed. Until in 2024, local residents who had grown tired of the silence finally organized a remembrance ceremony and brought the families back to the mountain. We now move to the Hawaiian hillside to a wartime fuel depot the size of a small city. The Japanese attack on Pearl Harbor on December 7, 1941, sank battleships and killed more than 2,400 people, but it could have been far worse. Millions of gallons of fuel that kept the entire Pacific Fleet running was sitting in plain sight in above-ground tanks beside the harbor. Had the attack destroyed that fuel, the surviving ships would have been stranded, and the Navy's ability to fight in the Pacific could have collapsed before the war even began. For some reason, the Japanese never targeted the tanks to expose this major vulnerability. The US Navy had already realized how dangerous it was to leave that fuel there and had begun construction on a solution a year before the attack. They were moving the fuel where bombs couldn't reach it, inside a mountain. Work started the day after Christmas, 1940, in the volcanic ridge of Red Hill above Pearl Harbor. The original plan was 4 horizontal tanks, but the design was later changed to a bigger scale. They would go on to build 20 enormous vertical tanks, each bored straight down into the basalt 100 feet across and 250 feet tall, large enough to swallow a 20-story building. Close to 4,000 workers dug in round-the-clock shifts, drilling a central shaft into each cavity and hauling out the rock on conveyor belts built by a tire company. When the attack came, the worksite was mostly underground and untouched. 8 construction workers above ground were killed by strafing aircraft. Seeing the urgency of the situation, the facility was finished in 1943, 9 months ahead of schedule. This underground storage facility held 250 million gallons of fuel under 100 feet of solid rock, connected to the harbor by pipelines running 2.5 miles downhill, gravity feeding fuel straight to the ships. It supplied the Pacific Fleet through the rest of the war and kept running unchanged for another 8 decades. But eventually, the rock that had protected the fuel for so long turned into a problem. The tank sat directly above an aquifer that supplied drinking water to much of Oahu. In November 2021, jet fuel leaked from the aging facility into the water serving Pearl Harbor, sickening thousands and forcing families from their homes. In 2022, the Department of Defense ordered Red Hill permanently shut down and defueled. Military strategists argued that closing it left the Pacific Fleet without hardened fuel storage at exactly the moment tensions with China were rising. But the contamination settled the question, and the tanks were drained. Almost all of New York City's water arrives through 2 tunnels. City Water Tunnel Number 1 opened in 1917 and Tunnel 2 opened in 1936. Together, the 2 tunnels carry over 1 billion gallons a day from reservoirs upstate to the taps of more than 8 million people. In nearly a century of service, neither of the tunnels has ever been shut off. Even though the tunnels have known leaks and are losing millions of gallons a day into the surrounding bedrock, fixing them requires shutting off the water. For decades, inspection of these tunnels has been simply impossible. That's because there is no third tunnel to carry the load while they do it. If one of those tunnels failed, large parts of New York could lose water for months, maybe longer, and there would be no way to fix it in time. The solution is City Water Tunnel Number 3, the largest construction project in New York City's history, and it has been under construction since 1970. The tunnel runs more than 60 miles, in places 500 feet below the street, bored through the hard bedrock under the city. When it's finished, it will give New York a third path for its water, and, for the first time, the ability to close tunnels 1 and 2 to find out what nearly 100 years of use has done to them. When approved, Tunnel Number 3 was described as one of the greatest construction projects in the history of Western civilization. It has come online in stages. The first section, running from Yonkers through Manhattan, began delivering water in 1998. The Manhattan section opened in 2013. The Brooklyn and Queens sections, the final stretch, serving the boroughs most dependent on the aging Tunnel Number 2, are now in their final construction phase, with completion expected in 2032. The people who dig these tunnels are called sandhogs, and they've been digging under New York for over 150 years. They got the name in the 1870s working on the foundations of the Brooklyn Bridge, down in sealed chambers filled with compressed air to hold back the river mud, where men got the bends coming back up too fast. Since then, the sandhogs have built nearly everything under the city, The subway tunnels, the sewers, the Holland and Lincoln tunnels, the foundations of the bridges and skyscrapers. Tunnel number 3 is their longest job, and it has held families across generations. Digging through bedrock hundreds of feet down has always been dangerous. The first stages were done with drill and blast. 24 people have died building tunnel number 3. 23 construction workers lost their lives by cave-ins, falls, and blasting accidents. The 24th was a 12-year-old boy who was exploring an uncapped shaft at a Bronx construction site and fell 500 feet to his death. The later stages got safer. A 300-ton tunnel-boring machine the sandhogs call the mole grinds a perfectly round hole through the bedrock with hardened steel wheels, moving about 100 feet a day. There have been no casualties since 1997. At the edge of Van Cortlandt Park in the Bronx, there is a memorial to the men who died building the tunnel. Most of the 8 million people drinking the water it will carry have no idea the tunnel is being dug, or that men spent 4 generations underground to build it. A lot of the places so far were built to protect against an attack. The next one was built to protect against something the country learned to fear in the 1970s, running out of oil. In 1973, the Arab members of OPEC cut off oil shipments to the United States. And within months, Americans were sitting in mile-long lines at gas stations, watching prices quadruple. The embargo exposed how badly the country had come to depend on imported oil and how little protection it had if that oil stopped flowing. In 1975, Congress created a stockpile meant to make sure it could never happen again. It was an emergency supply of crude the country could draw on if its imports were cut off. The question was where to put hundreds of millions of barrels of oil. The answer was salt. Beneath the coastlines of Texas and Louisiana lie enormous natural deposits of salt, pushed up from deep underground into formations called salt domes. Salt has a useful set of properties for storing oil. It's impermeable, so oil can't leak through it. It's stable, and under the pressure of being buried that deep, it slowly flows and seals its own cracks. Any small fracture in a cavern wall closes itself back up. The government chose to carve its oil reserve directly into these salt domes. To carve a cavern out of solid salt, they first needed to dissolve it. Drill a well down into the salt, pump in fresh water, and the water carrying dissolved salt is pumped back out as brine. It takes about 7 barrels of water to make room for every barrel of oil. By carefully controlling how the water is injected, engineers can hollow out a cavern of precise dimensions, deep underground, entirely by dissolving rock. The caverns are enormous. A typical one is about 200 feet across and 2,500 feet tall. A single cavern large enough to fit Chicago's Willis Tower inside with room to spare. There are 61 of them across 4 sites, holding a combined capacity of 714 million barrels, which makes the reserve the largest emergency oil stockpile in the world. The oil sites down there in the dark, costing a fraction of what it would take to store the same oil in tanks on the surface. Getting it out relies on physics. Operators pump water into the bottom, and the oil floats up and out the top, pushed to the surface and into pipelines that connect to refineries across the country. The system can release up to 4.4 million barrels a day, with the first oil reaching the market within about 2 weeks of a presidential order. In nearly 50 years, the reserve has been tapped in a genuine emergency only a handful of times. The Gulf War in 1991, Hurricane Katrina in 2005, the Libyan crisis in 2011, and the price spike after Russia invaded Ukraine in 2022. It is being tapped again right now. In mid-March 2026, in response to the closure of the Strait of Hormuz and the collapse of oil flowing out of the Persian Gulf, the United States announced the largest single release in the reserve's history, 172 million barrels, part of a coordinated release by 32 nations. That release drops the reserve to roughly 243 million barrels, the lowest level it has held since 1982. And the salt that makes the reserve work also limits it. Every time a cavern is emptied, fresh water is pumped in to push the oil out, and that water dissolves a little more salt, making the cavern slightly larger each time. Each cavern can only be drawn down a limited number of times before it's too big and unstable to use again. Reserve refills far slower than it empties. Oil released over a couple of weeks of crisis takes years and tens of billions of dollars to replace. The country's underground insurance against losing its oil is, slowly, dissolving itself a little more every time it's used. The Strategic Petroleum Reserve put oil into salt to keep it safe. 200 miles west, in the same kind of ancient salt, the country put something it needed to keep away from everything alive: the radioactive waste of building nuclear weapons. Building nuclear weapons produces toxic garbage in the form of contaminated debris of the bomb program itself. It includes the gloves, tools, rags, machinery, and protective clothing that came into contact with plutonium, soaked in the chemicals used to refine it. It is radioactive. It stays dangerous for around 24,000 years, and for decades the United States had nowhere permanent to put it. It sat in barrels at weapons sites around the country, including thousands of drums on a mesa at Los Alamos in New Mexico. The permanent answer is half a mile under the New Mexico desert outside Carlsbad, in a bed of salt 250 million years old. The salt is the entire reason the place exists. A salt deposit that old and that deep proves that groundwater has never reached it, and salt at that depth, under the pressure of everything above it, slowly flows, creeping inward to close any opening cut into it. The plan for the Waste Isolation Pilot Plant, or WIPP, is for the salt itself to do the sealing. Workers mine out rooms half a mile down, fill them with barrels of waste, and over time the salt presses in and entombs the drums, encasing them in a layer that water cannot get through and that will hold for longer than human history. WIPP opened in 1999, the only operating deep underground nuclear waste repository in the country, and for 15 years it worked. Trucks carried barrels of weapons waste across the desert, elevators lowered them half a mile down, and crews stacked them in the salt rooms to be slowly swallowed. Then, in February 2014, the system failed because of an extraordinary reason. The barrels of waste contain nitric acid, left over from refining plutonium, and regulations forbid storing liquid underground. So the waste has to be packed with an absorbent material to soak it up. For years, the absorbent of choice was a mineral-based cat litter, which is chemically inert and safe. At some point, the written procedure at Los Alamos was changed, and the wording shifted from an inorganic clay litter to an organic wheat-based one. It may have been as simple as someone mishearing a word in a meeting. Workers began packing the nuclear waste with organic cat litter, which reacts with the nitrate chemicals in the barrels. One drum, packed this way, was sealed, certified, trucked to WIPP, and lowered into the salt. 70 days later, half a mile underground, the chemical reaction inside it generated enough heat to pop the lid, and the drum burst. The breach sent radioactive plutonium and americium through more than 3,000 feet of tunnels, up the exhaust shaft, and into the air above the desert. 22 workers were contaminated. The radiation that reached the surface was detected at a monitoring station half a mile away. The only deep nuclear waste repository in the country had been shut down by a barrel of the wrong cat litter, and it stayed closed for 3 years with a cleanup that ran past $500 million. The accident exposed how much faith the whole project rested on. But the deeper challenge at WIPP isn't the chemistry of any one barrel, it's time. The waste will remain dangerous for around 24,000 years. When the repository is full, around 2033, it will be sealed and the salt will close over it. Every civilization that has ever existed is younger than the time this waste stays lethal. The government has commissioned panels of scientists, linguists, and anthropologists to design markers that could keep human beings away from the site for 10,000 years. WIPP was built for the contaminated debris of the weapons program, but it was never meant to hold the most dangerous waste of all, the spent fuel from nuclear reactors. That waste was supposed to go somewhere else, to a mountain in the Nevada desert, in a project that consumed decades and billions of dollars, and never accepted a single ounce. America has been generating nuclear waste since the 1940s, when the first reactors went operational for the Manhattan Project. By the 1980s, the situation was becoming untenable. Over 70,000 metric tons of high-level nuclear waste sat at more than 100 sites in 39 states, most of them near population centers, all of them temporary solutions waiting for a permanent answer. Congress decided in 1987 that the permanent answer would be Yucca Mountain, a remote ridge in the Nevada desert, about 100 miles northwest of Las Vegas. The location seemed ideal, geologically stable, extremely dry, far from population centers, on land the federal government already owned for nuclear testing. Plan called for tunneling deep into the mountain to create a repository that could safely store 77,000 metric tons of nuclear waste for 10,000 years. The waste would be sealed in corrosion-resistant containers and buried 1,000 feet underground in tunnels carved through volcanic rock, isolated from groundwater and protected by Nevada's arid climate. The Department of Energy projected that Yucca Mountain could open by 1998 at a cost of about $1 billion. Nuclear utilities would pay fees into a fund that would finance construction and operation, and America's nuclear waste problem would finally have a solution. The waste sitting in temporary storage at reactor sites could be transported to Nevada and buried permanently, eliminating the risk of accidents or contamination at dozens of locations nationwide. Nevada exploded in opposition. State officials, environmental groups, and residents near the site argued that the federal government was turning Nevada into America's nuclear dumping ground. The state hadn't chosen this. Congress had forced it on them through the Nuclear Waste Policy Act, which specifically designated Yucca Mountain after considering and rejecting sites in other states. Nevada had no nuclear power plants of its own, but would receive everyone else's waste. The other candidate states, Texas and Washington, had the political weight to get themselves removed. Nevada had the most junior congressional delegation in the running, including a newly elected senator named Harry Reid, and it didn't have the votes to stop it. Nevadans have called the 1987 amendment the Screw Nevada Bill. Despite Nevada's opposition, site characterization began in the early 1990s. The Department of Energy started extensive geological studies, drilling boreholes, conducting seismic surveys, and analyzing the rock formations. A 5-mile exploratory tunnel was bored into the mountain using a tunnel boring machine that carved a passage 25 feet in diameter through the volcanic tuff. The tunnel allowed scientists to directly examine the geology and test whether Yucca Mountain could actually contain nuclear waste as predicted. The geological studies revealed complications. The water table was higher than initial surveys suggested, meaning contamination could potentially reach groundwater faster than models predicted. Earthquake faults ran closer to the site than originally thought. The volcanic rock was more porous in some areas, raising questions about how quickly radiation could migrate. Each discovery required new analysis and revised predictions, and Nevada's opponents used every finding as evidence that the site was unsuitable. The cost estimates started climbing as the technical challenges became clearer. By the late 1990s, projections reached $8 billion. By 2005, estimates hit $15 billion. The 1998 opening date had long since passed, replaced by targets of 2010, then 2017, then 2020. Each delay cost money for ongoing studies and maintenance of a site that wasn't accepting waste. In 2002, after years of study and debate, the Department of Energy officially recommended Yucca Mountain to President Bush, and Congress approved it over Nevada's objection. The Nuclear Regulatory Commission began the licensing process to authorize construction. The repository seemed on track to finally open in the 2000s. Then, politics intervened decisively. Barack Obama won the 2008 presidential election with strong support from Senate Majority Leader Harry Reid, a Nevada Democrat who'd made stopping Yucca Mountain his personal crusade. In 2010, the Obama administration announced it was terminating the project. The Department of Energy withdrew its license application with the Nuclear Regulatory Commission, defunded the program, and created a commission to study alternatives to Yucca Mountain. The cancellation came after spending over $15 billion on studies, tunnel construction, and licensing work. The 5-mile exploratory tunnel was complete. Detailed geological characterization had been done. The license application was pending. The project was years away from actually storing waste, but billions had been spent proving the site was viable. Nevada celebrated the decision as a victory. Federal officials who'd spent careers working on Yucca Mountain were reassigned or retired. The facility that was supposed to solve America's nuclear waste problem was abandoned, and the waste remains exactly where it's been for decades, sitting in temporary storage at reactor sites across the country. The Yucca Mountain site still exists, essentially mothballed. The exploratory tunnel is there, sealed but intact. The surface facilities are maintained at a minimal level. The waste problem Yucca Mountain was supposed to solve hasn't gone away, it's gotten worse. Over 90,000 metric tons of spent fuel now sits at reactor sites, more than Yucca Mountain was designed to hold. Some reactors have shut down, but can't fully decommission because their waste has nowhere to go. The temporary solutions from the 1970s and 1980s are still in place 50 years later, with no permanent alternative in sight. Congress occasionally discusses reviving Yucca Mountain. The Trump administration tried to restart the licensing process in 2017, but faced Nevada's continued opposition and couldn't secure funding. The Biden administration showed no interest in pursuing it. The political dynamics haven't changed. Nevada still opposes the repository, and no other state wants to volunteer as a replacement. The waste continues sitting in temporary storage because the permanent solution was abandoned after $15 billion and 30 years of work. The political opposition from Nevada, combined with changing federal priorities, killed a project that was closer to completion than most abandoned megaprojects ever get. Yucca Mountain and WIPP were attempts to put the bomb's worst byproducts underground. For about 20 years, the United States studied the opposite idea, setting nuclear weapons off on purpose to build things. In 1957, the United States launched a program to develop peaceful uses for nuclear explosions. It was called Project Plowshare, after the verse about beating swords into plowshares. And the idea was to use nuclear bombs the way you would use dynamite, scaled up by a factor of thousands, to move Earth, carve channels, and dig in a single blast what would otherwise take years. The man driving it was Edward Teller, the physicist known as the father of the hydrogen bomb. Teller traveled the country promoting what he called geographical engineering, reshaping the land with nuclear explosives. His pitch, delivered to audiences across Alaska and beyond, was that the bombs could blast harbors into coastlines, break open mountains for highways, and crack the rock to release the oil and gas trapped inside it. If a mountain was in an inconvenient place, the line went, the government would be happy to move it. The first serious proposal was Project Chariot. The plan was to detonate a chain of hydrogen bombs off the coast of northwest Alaska near the Inupiat village of Point Hope to blast an artificial harbor into the shore. The original design called for bombs totaling 2.4 megatons, about 160 times the force of the bomb dropped on Hiroshima. Teller promoted it as economic development for the newly admitted state, and the local chambers of commerce, the university, and the state's largest newspapers lined up behind it. The harbor would have sat on a coast frozen 9 months of the year, with little traffic to use it. What stopped Chariot was the science Teller had commissioned to support it. University of Alaska researchers studying the site found that fallout behaves in ways the program had ignored. In the Arctic, lichen absorbs radioactive material from the air with unusual efficiency. Caribou eat the lichen, and the Inupiat eat the caribou, and the radioactivity concentrates at each step up the chain. A blast 30 miles from Point Hope would end up inside the people who lived there. In 1961, the village council wrote to President Kennedy opposing the plan. Chariot was quietly shelved, and decades later, researchers discovered that the site had been contaminated anyway by an experiment in which radioactive material from a Nevada test had been trucked to Alaska, used to study how fallout washes through the tundra, then buried in a mound and left there. The blasts that did happen showed the same problem. In 1961, Project Gnome detonated a nuclear device in a salt bed near Carlsbad, New Mexico, the same kind of salt that would later hold WIPP. And the explosion that was supposed to seal itself vented radioactive steam over the press gallery brought in to watch it. The following year came Sedan, the largest cratering shot, a 104-kiloton blast in the Nevada desert designed to test whether nuclear bombs could excavate. It displaced 12 million tons of earth and left a crater 320 feet deep and a quarter-mile wide. It also threw a radioactive cloud into the sky that drifted across the country, depositing fallout as far away as Iowa and South Dakota. Sedan exposed more Americans to fallout than any other test in the program. The most promising application, on paper, was using the bombs to fracture rock and release natural gas. 3 times the program tried it, in New Mexico and twice in Colorado. The blasts did free the gas, but the gas came out radioactive, contaminated with tritium, and no utility could sell it and no household could burn it. Project Rulison in Colorado cost around $11 million and produced gas worth a fraction of that, all of it unusable. By the early 1970s, citizen groups were suing to stop the tests, concerned that the blasts would poison wells or trigger earthquakes. The program had spent something like $770 million across 27 nuclear detonations, and it had not produced a single harbor, canal, highway, or marketable cubic foot of gas. Funding quietly ran out in 1977. The most ambitious plan was never carried out at all. For most of the 1960s, the program studied using nuclear explosives to dig a second Panama Canal, a sea-level waterway across Central America, cut by hundreds of nuclear blasts detonated in sequence through the isthmus. Routes were proposed through Panama, Colombia, and Mexico. The canal would have been wide enough for the largest aircraft carriers. It existed in studies and commission reports and detailed route surveys, and the only thing that kept it from leaving the page was that everything the program had learned by then pointed to the same conclusion. You cannot set off hundreds of nuclear bombs near where people live without poisoning the ground they stand on. Every place in this story so far is documented. Things that were built, have records, can be visited or confirmed. But the same secrecy that hid them for decades created room for something else to grow. The belief that what's been revealed is only a fraction of what's really down there. For most of their existence, the real facilities in this story were secret. Raven Rock wasn't acknowledged. Mount Weather was found out by accident when a plane crashed into it. The congressional bunker under the Greenbrier Resort stayed hidden for 30 years, disguised as part of the hotel until a newspaper exposed it in 1992. For decades, the government's response to questions about these places was to neither confirm nor deny. But here's the problem. If a government builds entire towns inside mountains and refuses to say they exist for years, then it makes almost any underground rumor sound plausible. Out of this problem grew a much larger belief that beneath the visible country, there is a hidden one, a network of secret bases connected by tunnels, vast underground cities, a whole second infrastructure built away from public view. The most famous version centers on Denver International Airport. The airport opened in 1995, late and far over budget, built on a stretch of prairie much larger than the city seemed to need. That combination, the cost overruns, the strange delays, the sheer size of the place, fed years of theories that the real project was underground. Secret levels beneath the terminals, bunkers, tunnels stretching for miles, a command center for some hidden purpose. The airport's odd public art, including a mural of a figure in a gas mask and a towering blue horse sculpture with glowing red eyes, gave the story's fuel. The airport has leaned into it, putting up its own tongue-in-cheek signage about the conspiracies. What's actually documented underneath is a failed automated baggage system and the standard tunnels any major airport has. The broader claims go further. A former government official named Catherine Austin Fitts has argued for years that the United States has spent trillions of unaccounted-for dollars, some of it on a hidden infrastructure she and others describe as a breakaway civilization. a separate, technologically advanced society operating underground and out of sight. There are claims of tunnel networks linking military bases across the Southwest, of underground facilities far larger than anything admitted. None of it has been documented in the way the real sites have. There are no construction records, no workforce, no verified entrances. The difficulty is what sits underneath all of it. The reason these theories are hard to dismiss out of hand isn't that there's evidence for them. It's that the documented reality already sounds like a conspiracy theory. A duplicate Pentagon hollowed out of a mountain, a bunker for all of Congress hidden under a resort for 30 years, a command center built to survive a nuclear war on 1,000-pound springs, helicopters that fly over Washington every day to evacuate the government to bunkers most people have never heard of, a program run for decades and costing billions, built to save a few thousand people while everyone else was left behind. All of that is real, and all of it was secret. The line between what the government actually built and what people imagine it built is genuinely hard to draw, because the real version spent 50 years being denied. The underground America we've explored today sounds unbelievable, yet almost every one of these places began as a secret. So the question is, if entire cities can exist beneath our feet without most people ever knowing, what else is still down there? Comment your thoughts below and keep following SIGNUM for more fascinating stories from the world's most impressive megaprojects.